Okay, everyone. Thanks for joining. So today we are going to start with the leg robots, and then we will be going with the projects. Okay. So um, I was planned. I actually planned to shortlist some projects before, but I couldn't do that because of so many reasons. Main reason is obviously uh, work. So this session, maybe in this chapter, we are discussing that. I mean the same thing. So I think we can shortlist some projects from this chapter, and then we can plan to do. Okay. So I can mention some of the projects that students actually done on the previous course, and also I can also discuss this chapter is not about talking about specific projects, but I can show the possibilities. So what are the things that we can do with ROS, robotics, computer vision, all this stuff. Okay, so that is the intention. So you can able to see a list of possibilities that you can able to take and do it as a project. Okay. So last class we have been discussing about the leg robots, and we have seen up to the sport robot simulation in Gazebo. And today I mentioned that uh, we will be discussing that simulation. We will be starting from that. Then we will be seeing some hardware discussion, like what are the things that we need to make if we are planning to prototype a leg robot. I mean, a mini version of the leg robot. Okay. Then finally we will see a project called Open Dynamic Robot Initiative, another open source project. Okay. Then we will conclude this chapter and jump into the projects. Okay. So that is a plan. So yesterday I have shown you, just a second, let me close all my social media. And yeah, so this was one project that I got from internet. Like when I search about sport robot simulation, I think this company actually created this, but it seems like not very updated, but it will work. But there are some patches that we have to do in order to make it work. So basically, this project now, I think I have shared the link before. Maybe I can do that again. So if you simply follow the instructions are basically like cloning the repo, then building it. So that is the instruction we need to do. These all are the packages. So it is having the RS description, is having the sport model. Then gazebo is having the simulation related stuff. Control means the controller, which is driving the robot. Then inverse means it is having the inverse kinematic script. Currently, I think there are some problem with this script, so that if we give a position, or if we want to move the robot to some XYZ, then the robot will go to that, something like that. Yeah, so these are some packages available, and you can simply follow this instruction. Basically, first they are mentioning about the setting of the simulation on Docker, okay, using NVIDIA Docker. But uh, I will say better is to try with the source code, so you will get an idea. You can try it with Noitic. They have tested with Melodic, but mostly it will work with minor tuning. Okay, so I have set up this project in my VMware, and yesterday I have shown you, right? So I'm simply following these instructions. So I'm first, the command is that starting the headquarters, meaning the world. Okay, so we can see the gazebo is popping up with the world, um, an office space basically. And yeah, so this is a world file. Okay, so basically, the project aim to uh, spawn the robot here. Almost we can decide the position anyway, but by default it is going here. Okay, so to spawn the robot, you can simply copy paste this command and run it. So while running the control of this launch file, you may get an error regarding robot state publisher. So there is a name change in the robot state publisher node. So if you fix that, I think it will work. So here, if everything is working, then you can able to see the spot robot in the simulation. Okay, maybe we can delete this world. Okay, yeah, so that, I mean, we don't need this anyway, we just need the robot to be, yeah. So this is a robot. So basically this robot model, no, this robot model basically got from ClearPath Robotics. They have published the spot robot description and also the driver. Okay, and these company that we are currently looking, they actually taken this model, then created the simulation of it, and then assign a controller so that it will drive the robot. Okay, yes, and in order to move, I have seen a control like if you want to do the forward kinematics, basically like just setting the actuator values. If you want to move the robot, I think the forward kinematics is working fine. You can see the robot start moving. Just a second. Yeah, so it's basically like the joint movement, not the inverse kinematics movement. It's basically sending the values to the joint, but it's quite stable, right? It's balancing, and yeah, yeah, it's actually mimicking different motion. Yeah, yeah, interesting. Hmm. Okay, so that command is actually working, and this is the result. And if you check for the inverse, actually the inverse is not working. I think the GUI also, there was some issue with TK in their library. Let me try the GUI. They are providing some GUI for inverse kinematics. Let me see. The GUI was working. So here the intention is we can mention the X value, Y value and all, but I didn't see this is working. The GUI is popping up, but yeah, I think we can send it or something, but unfortunately I couldn't make it work. Yeah. um yeah, and there is a keyboard teleop as well, but for working with that, I think we need to run this launch file. Let me try. So I'm just demonstrating this. The instructions are in the readme. This is just a project. Maybe you can also take this project and modify like an open source contribution, because if you check this repository, I couldn't see the version for Noitic. So maybe I will discuss these things in the next chapter, the projects. Yeah. So right. We can start the teleop. I'm not sure which is work or not. The teleop is coming, but the robot is not moving anyway. I have tried that. Yeah. Yeah, there are some issues with the teleop. So basically, oh, okay. So this is a simulation. We have the simulation and the controller ready, so we can make use of it. We can actually use it as a project as well. Okay. Maybe we can improve this project by fixing the bugs. We can see that on the next chapter. Okay. So regarding the sport robot, I have something to show. That is, yesterday I have mentioned sport robot SDK. So this is an important stuff. Like, if you have a luck to work with the actual sport robot, okay, because I specifically say luck because you can find this robot mainly in universities, and also there is no I mean guarantee that you are going to work on this, because if you are going for masters or if you're working in a company, I mean, your project may not be this, right? So if you have luck or if you are interested in working with sport, this is one thing you have to check. This is a SDK that Boston Dynamics gives to us. It's a Python based SDK, I guess. So in this SDK, we have APIs, okay, APIs. And using this API, you can control the entire things of sport, okay. So basically the sport can be controlled using joystick, and you can also interface many sensors into the computer. Also we can interface external PC into it. So all these values, all the things, it's like a readme for the sport, okay. And also the yeah, the Python APIs for handling the yeah, and there are some choreography. So I mean, the SDK is having almost all the things for doing this kind of movements, okay. So this is an important piece of software uh, we we are getting, and this is actually available in GitHub. So if you just go to GitHub, I think it is available. Just a second. Yeah, sport robot SDK GitHub. Yeah, so this is the repository for sport SDK. You can see they are mentioning about most of the stuff. I mean, this SDK, but unfortunately, I will say it is only supporting Python. That is not very good, I will say. Um, they don't have any C++ APIs. They mainly have the Python APIs. Okay, anyway, like it's all like control commands, so we may not be, I mean, process like high end or high bandwidth data, I think. There are tons of examples as well. Oh, okay, so not only control commands, they are, I mean, examples for getting the image from spot. Then yeah, okay. Okay, so in order to get the values from Velodyne, okay, so this is actually the example. Okay, so we can simply integrate these SDK into ROS. Okay, so there are two methods to work with ROS and sport robot. The first thing is that the sport driver that is released by Boston Dynamics. So we can use it because they already created the driver. So I think mostly what happening is that in this driver they are using the SDK mostly. Okay, see, there is a code called sport wrapper. I think it is wrapping the SDK. Okay, so these all are the SDK calls, I mean SDK modules. So the driver is simply a Python class, and which is exposing each APIs as ROS topic. So you may be thinking like how to make a ROS interface from an existing SDK or something. So for Spot SDK it is like that only. So what is happening is that the ROS interface means so what are the main things that we are using to work with ROS topics, ROS service, parameters and all, right? So ROS integration or ROS ROS interface means you can interact with the robot or any sensor or actuators using topics, service, action, or like parameters. I mean, the ROS concept, using the ROS concept, you can communicate with them. Okay, so what ClearPath does is that even we can do this, okay, but they have done in a better way. They have exposed all the APIs, all the important APIs of Spot, and when we run this driver we will get topics. Okay, then we can simply write a note to publish some values to the topic. Okay, recently I worked with a robot called Kinova. Kinova, it's not Jacko, Kinova, I forgot the name, exact name, but the company name is Kinova. So they do have the same kind of SDK and driver, so that when you run the ROS driver, it is exposing all the APIs in the SDK. So in order to start the robot, you can simply call a service. In order to like move the robot, you can simply call a service. I mean, everything is exposed as a service. So that is the driver. Okay, so driver there. So either we can use the official driver or we can simply use some examples of Spot SDK and include the ROS Python modules. Okay, yes, that is one thing I forgot to mention. And yeah, so I think we have discussed that, and now I think we can go to the second last thing, like this one, prototyping lessons. So what we are planning is that we can see what are the basic circuit or basic thing needed to prototype a legged robot. So this project, what was that project? Yeah, Spot Micro. I found this project very impressive. It's also looks good, and their design, 3D prints and all, everything is shared. Okay, yeah, and they also mention the step file. Everything is actually public, so we can able to 3D print the model, and I think the complete the complete project is open source. That include circuit, everything. Okay, so that is interesting. So these all are some of the replicated projects that you can see. You can see the 3D printed parts. Then yeah, not only that, I think there will be circuit as well. Let me see. Yeah, these all are parts only. You can also check the repository, the components they have used. Everything is actually mentioned. So it seems like it's very impressive. Yeah, they have shortlisted the devices they have used. They have used ESP32 for the microcontroller. Then there are servos they have used for the movement, and yeah, then gyroscope. So there are tons of devices or sensors. Interesting. Yeah, so maybe we will find the assembly guide and electronics. Maybe this is the assembly instruction. Yeah, so after doing the 3D printing, the assembly instructions are there, and also the electronics. This is one important part. So for the electronics, it seems like they have used the ESP32 board, and this is the complete schematic of the robot. So the basic thing is the ESP32, and there is another ESP32 cam. I'm not sure of, what is the purpose of it. It may be for the display or something. And this ESP32 is interfacing to ultrasound sensor. Then I think the servo. Yeah, so this is the PCA 9685. That board actually used for controlling multiple servos. So yeah, and this seems like, yeah, it is having everything, I think. ESP32 servo board. Yeah, so basically this robot, maybe I can share this link as well. This robot having 4 servo, right? 4 servo, it seems. And these 4 servo has to be controlled, and there is a servo controller board, so that the ESP32 board can send some messages like which servo has to control. So the servo controller board will control it. Okay, so yeah, so that's it. So these are some examples that you can find. I think this is also, yeah, this thing inverse is also, I think, interesting. You can able to find different designs. So someone mounted the LiDAR so that we can use for mapping. Yeah, interesting. Yeah, so basically what I'm planning to say is that, like, the robot, if you are planning to create a legged robot, basically it's a combination of like 4 or 6 servos, which is having a microcontroller and also a servo controller board. Okay, then battery and all the stuff, and the ESP32 or the microcontroller board may be controlled using some Raspberry Pi, or some, maybe it can be remotely controlled from the laptop. Okay, because ESP32 is having Wi-Fi, so we can communicate wirelessly as well. Yeah, so these are some interesting stuff that is going on with the sport robot. There are many designs, so you can get it simply by searching. Yeah, okay. Okay guys, I think, yeah, so these are some of the hardware related stuff, and now we are jumping into the Open Dynamics project. I'm not sure you have heard about the Open Dynamic robot. Yeah, it's an interesting project, guys. So again, a project related to legged robots, quadruped. So here, I think, let me check the university. Yeah, NYU, New York University. They are working on this project. I think they are also collaborating with some universities in Germany. So you can first check this video. Okay, it's pretty interesting, and they also have a GitHub. I mean, organization, GitHub organization, which is having all the designs. So it's an open source project, and so let's watch the video. Okay, so you can see here, it's a very simple design, and there are 4 motors, not only 4, I think, seems like 8. Let me check. Yeah, they started with the single actuator, so seems like 2. Yeah, so they are starting with the single leg, and they are like testing the drop. Yeah, they are doing the drop test, checking the impact. Yeah, so this is the complete setup, and you can find that this is a very lightweight robot. It's not having I mean, it's not replicated from the design of Sport. Basically, it looks like very portable and very efficient, I will say. Yeah. So you can also replicate the same using their design, but yeah, they are doing more testing with this. All these joints, main joints, is having BLDC motors, controlling using torque, I think. Yeah, interesting. Yeah, it's like jumping like a cat. It's interesting. Yeah. So this is a kind of like, yeah, uh, kind of demo of this project. You can see it's very simple, and on its body, I think all the control modules like the motor control and also the computer are mounted. Yeah. So this is the Open Dynamic robot project. Uh, it is having an organization GitHub link you can see here. So they actually sharing all the hardware details, then mechanical detail. Hardware includes electronics, mechanical, all the things they are mentioning. So we can replicate it, and yeah. So and also they have a base paper here. So yeah, this is the base paper. Maybe I can just scroll through this. Yeah, open torque control modular robot architecture for locomotion research. You can find they are mentioning like all the things, including the electronics connection. Like uh, basically they have a set of motors, okay, which is controlling through the driver, and we have to provide the power supply, and these motors are having encoders as well for the feedback, and the encoders motors are controlling by the microcontroller, right? And uh, the microcontrollers are communicating through a CAN bus. CAN is a protocol like the RS-232, and the high level thing is happening in a Linux machine, in a real-time Linux machine. So I hope you heard about the Linux, real-time Linux. Like we can make the normal Linux, that is the Linux that we are working. This is mainly for desktop application. If we want to make it as real time, or if we want to make it use for like robotic application, we need to change some parameters in the kernel. Then only it will work for real time application. So that's what they are using for this project. So they have mentioned everything. And for the microcontroller, they're using Texas Instrument microcontroller, and yeah, they're using embedded C for that. And all the information is there. Maybe I can share the link for this base paper as well. Okay, so just have a look on to the base paper, guys. uh, yeah, I think it's a very cool project. Yes. So these are some of the things that I have to mention regarding the leg robots. Now we can get started with the projects. Okay. So it will be more like discussion, and I can throw some ideas to you, and you guys can plan based on your time. Okay. So first, I'm starting with the projects and how I did for the first batch of RDLP. I mean, the first batch was obviously 1.0. So let me take my GitHub. Just a second. Let me just sign in to Robo Academy. Just a second. Okay. So fine. RDLP. Just a sec. Yeah, maybe okay. I hope you have seen that link. So for RDLP 1.0, uh, I have the same intention like doing the projects, but for them I actually uh, I mean told to work with some innovative idea, and then I have actually shared some thread, but everybody was interested to innovate. So that was actually I am also happy about, because if you innovate, or if you can come up with some interesting cool idea, then maybe you can discuss with me like whether it is feasible or not, then you can start implementing it. So like it should not be having a real application, it may be a game or something like that. The intention is learning. So here is Shakti, he actually created a snake game using the turtle sim. I mean, even I didn't thought about this kind of cool idea, but we can able to implement. So these all are very initial projects, but do you think this can be done very easily? No. Okay, it's not very easy. So when I'm uh, like taking workshops or like instructing someone to learn ROS, the main stuff that I am communicating to them is we will get the theory, we will get the content from anywhere from the internet. So if you just simply search for like ROS tutorial, you will, I mean, get tons of tutorials. And there are like academy, online academies are available. But what is not available is that uh, like some mentors. I mean, there are few mentors, but I will say the mentors who can help for implementing the project or like guiding you. I mean, in a very high level, because the importance of doing projects in any technology is that you can only learn if you do. That is the truth. Okay, that is the truth. If you learn ROS 1 or ROS 2, the concept, when you start working on it, then only you can understand the difficulty. Okay, so what I will say is, obviously we have to start doing things. That is the objective of any, I mean, like if you try to learn any technology, this is mandatory. So the first question is, how can we start? Like in which level we can start? So we have learned multiple stuff from the very beginning to some advanced things, but I will always suggest you to start from the scratch, from the very simple concept. Okay, not from the turtle sim, I will say, from the publisher subscriber, very basic thing. Maybe I can show you just a second, one simple assignment. I mean, it was not very simple, like it looks like. Yeah, so this was Jarin. He also helping this course now, in this course. So he's an undergrad. He was there in my previous course. So one of the first task or like project that I have given to him was chat application. Okay. Now also I have given this task to a few of the people who are starting to learn ROS 2. Okay. Even to my wife, I have given this same task. So you may be thinking like, yeah, we have seen the talker listener. Yeah, it looks like simple, right? It looks simple, but if you want to create an application that can take the user input and I mean, like a Facebook chat, if you want to create a basic chatting application using ROS 1 or ROS 2, then you will think about the complexity. I mean, you learn talker and listener, that I agree. But if I'm saying to apply it to an application, then the real challenge begins. Okay, so that is why I actually I mean mention uh, to him to start from very basic. So here we may need to yeah, there is a demo video GIF as well. So it's like it's waiting for message like one is typing from here and the response will get in the other terminal, something like that. So you may be still thinking it is simple, but can you try to implement? I mean, without checking this code, can you try to implement a simple chat application? I think you have learned a lot of stuff in ROS 1, right? But you can understand the difficulty when you start doing the basics. Okay, so even if it is difficult, keep on doing it. Okay, so that is my suggestion for the entire course or any course. I'm not believing that like doing a predefined assignment may teach you something. One thing I don't like about assignment is that some assignments we don't like actually. In Coursera or Udemy or some other website, they I mean they are forcing us to do some assignments. Okay, then only we will get the credit, or then only we can complete the course. Okay, imagine I'm not interested to do that assignment, maybe the concept. Okay, for example, I am giving you a fixed assignment like this chat application. So maybe one or two people may having interest, but most of you don't have interest. So I will not say like do the things that you are not interested in. Okay, it's like a forceful thing, but that's where the innovation comes. So you can work on some concept that you are really interested in and then try to work on it. So the one positive things about it is that you are really liking it, liking that concept. Even if it is a stupid idea, maybe with some modification you can create it. So you have that interest or you have that passion to complete it. Anyway, like even if you are interested or even if it's a force assignment, it will be difficult. That is for sure. Okay, so just admit that like when you start doing projects, you can understand. Okay, it's difficult, but the challenge is that the consistency. Okay, like even if you do a small project, even if you are doing a big project, the consistency actually matters. So that's why I even started a group here in RDLP 1.0 motivation channel. I mean, it looks stupid, right? What is the use of a motivation channel in a tech course? So there is actually. So there are two kind of motivation we require. One is like when you start doing project now, not only project, when you enroll to this course. Okay, so about like 30 to 40 students are enrolled in this course. But how many people are attending live sessions? Like if you regularly check, it is around like less than 10. So these guys are like attending from the day one, and they are like continuing the course. Others are like paying the fees, but they are not attending. Maybe they lost interest, and that is quite natural. So that is where we need the motivation. Like everyone is, I mean, everyone is very interested to start, but very less people are can maintain that course, or like consistently do that course. So that is actually a skill, or I will say that is good for you, because you keep on doing it, and you will get some result for sure. Okay, so that is the first place you need the motivation. And the second place is like the inertia when you start doing projects. So for example, I am keep on taking the lectures, and then when you start doing it, you find it as very very difficult. So you will drop, because nowadays, no, even for me, I mean for the new generation, I will say the attention span is very very low. Okay, like we are living in a world of reels and TikTok. So basically, like, we don't have patience to do it. So once you like write a code, and if it is not working, you lost the interest, you lost the motivation. So how we can pull the motivation? It's very difficult, actually. It's very difficult to answer that question. But I will say the only way is consistency. Like consistency and love, I will say. Like if you are loving the things that you are doing, then at least you are, there is a chance to uh, I mean be consistent in that. Okay, so like just like what you are currently doing, and then consistent, be consistent, then only we can achieve these kind of bigger challenges. So this is a common thing for all the technology. Okay, so before start doing the projects, maybe some of you have already started doing projects, but what I'm saying is, if you are planning to start new projects, then the consistency is a key, otherwise you can't able to do. And the fact is that the reality is that doing projects is very very difficult. Then it will take a lot of time of you, and the final uh, the what uh, the result is that you can learn the concept, and you will be confident. That is the um, that is the output that you are going to get. Okay, you will be confident. And maybe you may be starting from the chat application, you may be spending 3 4 days for it, but you know what is experience? I'm not sure your definition of experience, but in reality the experience is the number of times you failed, right? So like you tried one concept that didn't work, then what actually happening is that in each failure you are learning multiple stuff. But just imagine, in the first try itself, if it is working, then literally you are not learning. So there is a saying like, if you are successful, you are learning nothing. But if you are failing, then you are learning many things. So this can be applied in our projects, any projects actually. Okay, so I will say, even I am actually trying to, it's very difficult to believe that concept for me as well. But it will be better if we believe in that way. I mean, the reality is like that only. If you fail, you will learn. And that is we are calling experience. Maybe from my experience, I can say that I failed. I mean, I didn't count actually. I failed many times. Then only I can learn stuff. I mean, it's not a planned failure, but obviously we will fail, because while doing stuff we don't know some concepts, so we will try to learn, then we will implement, you will have tons of error, then we will try again. So the key quality that you need is the patience. So keep on learning, keep on learning. uh, there is a saying like there will be a light at the end of the tunnel, right? So something like that, like you can achieve these things only with the patience. Okay, so this can be, I mean, you can take this concept not only for ROS robotics, for everything. Okay, so I'm just saying because my experience is like that. And when I talk to other people also, like those who are learned lot of stuff, a lot of experience compared to me, they're also saying the same thing. The thing is consistency, and we will keep on I mean, the failure is a part actually. And don't target on success. And like, if you get the success in the first time itself, there is no what thrill in it, right? Actually the reality is that, like, if you get if you get everything in the first try, then it's not, I mean, maybe at first time it may be okay, but if you keep on getting the things that we want, then there is no challenge and there is no growth. Okay, but when you start doing this, we will get all these things. Like you will be consistently, I mean, constantly failing, and you should be consistent all the time, otherwise you can't do any projects, not only ROS. Okay, so regarding the projects, I will say you can start from very very small project like chat application that I mentioned. You can try to do maybe, or some projects as per your interest. Okay, using publisher subscriber. Then you can just start with some turtle sim based. So you may have some thinking like, so what is the purpose of working with the turtle sim? We have many big things to do like gazebo, navigation stack. Yes, we will do that. But if you are not uh, if you are not uh, like building your foundation strongly, you have to come back. This is happening for most of the people. Even I have some personal experience. I have tried to teach ROS personally, and what happened was they were very confident. Oh, it's very easy to learn. Navigation stack is this much only. Move it is this much only. But when they start doing, they started failing, and then they came back to the initial concept. What is the initial concept? It's a publisher and subscriber. So this can be there. Okay, so what I will suggest you is that make sure the core concept like topics, subscriber, publishing, all these things are clear to you. And one important thing is that if you have the basic knowledge of ROS 1 concept and ROS 2 concept, like if you are learning ROS 2 additionally, then there is a chance to get internship. Like even if you are planning to do internship or something, the basic idea, basic concept is very important, because they will be asking you the basic question. So if you create a project by changing something from the GitHub, and if you don't know about the concept, then I don't know that is good or not. Okay, so I have some reference for sure from the previous students, like France. He actually got the best ROS developer award from the RDLP 1.0. So he actually was working while doing this course, and he created a portfolio like this. Okay, there are some good portfolio he have created from the very basics, to some mobile robots, something. Okay, so he created, and so this is one of the famous project. I even mentioned this project in my one of my book, diffbot, basically a differential drive bot. So it is using the turtlebot environment, but the robot is actually different. Okay, it's a different thing. And yeah, so he's also having a blog. Maybe I can share this link. There are many other profile. Maybe I can share that maybe in the next session. So this is just a start for the project. Okay, and this is a website, and so this is a portfolio. Like this GitHub link, you can put it in your CV or in your CV. Yeah. So here you have to expose all the things like the social media, blog, then video, your work, everything you can put it. Okay. So if you have any code development based project or something, and the company can check your source code, so they can understand your coding style, all this stuff. Okay, so these all are some projects that you have done, and yeah, so there are many other, I think 5 or 6 people who have done actually very excellent projects in the last course, and yeah. So the doing of project is one thing, and next is the contribution to open source. Okay, so after explaining that, I'm just concluding today's session, and then maybe in next class or something we can talk about maybe individual projects. It will take some time. So I don't know, you are aware of the open source contribution. In the first class, in the first lecture, I have mentioned all this stuff, but maybe I can explain it again. The open source contribution is nothing but like collaborating with someone's project and add some features or fix some bugs. Okay, for example, Jerin actually created a four-wheeled robot, and this is an open source project. Okay, so you are trying to learn this project, or you are trying to do this project your own, and you found some issues. Okay, you found some issues. So now what you can do is you can just fork this repository. Fork means you can clone this repository in your profile and then create a branch in your repository, and then you can give a pull request into this actual repository. So the idea is that giving a pull request or PR means it is actually a fix. Like you are saying, hey Jerin, I have found an issue and this is a fix. So if you are interested, you can merge with your code. Okay, so for example, if you check the pull request in diffboard, you can see here, just open the PR. So here the actual branch is ROS Mobile Noetic Devel, and this person Nidhi is giving a pull request. Okay, so the pull request is like there are some changes. If you check this, you can find some header file she have added. Okay, and so if the author is happy with this pull request, he can merge this code into this main branch. Okay, so why it is important? So adding a pull request or giving a pull request is a community contribution. It's a contribution actually. In if you are working with ROS, no, the ROS community is mainly open source. Okay, so if you have time, then contributing to the community is actually, I mean, that is what the community works, right? That is how the community works, because if you are simply consuming it, that is not the way of community works. We are also need to contribute, and the contribution can be in a form of new projects, new open source projects, then writing documentation, creating tutorials, then fixing bugs, adding features into an existing projects. All these are contribution. Okay, so you may be thinking, okay, I am trying to like simply consume, I don't want to contribute. So again, there is a problem. Like if you are if you are planning to get a job, or if you're planning to get a research or internship, anything, the open source contribution actually matters, because it is also a measure of your activities. Like, if you are very active in the community, that means you have good idea about that technology. Also, if you are contributing to a bigger project, then that means that actually proves that you can able to work with bigger projects. Okay, more than that, more than these skills, you will get tons of contacts. Like here, like for example, if you are working with this project, and you are giving pull requests, then France will get to know about you. There is a chance to contact France. Okay, so we can get in touch with many developers. Okay, so through that you can get opportunities. So for example, um I am also doing contribution, but in a very I mean not in a very high level, but I actually interested to do, but because of my tight schedule in the projects, I couldn't able to. But I actually did a very small contribution in that what darknet. Maybe I can show you that, and I can explain what happened after that. Okay, it's very interesting. Darknet. Uh, it's not the main repository. I think YOLO v4 GitHub. So when the YOLO v4, the version 4 released, I actually done a very basic modification. Let me check. I don't know the main repository. Um, yeah, I have done a very basic modification. Okay, and then I created a pull request, and they accepted it. Okay, then what happening is that when you contribute, that contribution will be added to this list. Okay, this list. So lot of people are like using this repository, so just check how much people, I mean how many people are using this. See, 12.1k, 12,000k folks, 33k stars. It's very famous than ROS, I will say, the YOLO v5. Okay, single project. So you can imagine the scope of this project. Millions of people are visiting this project. And what happened was, like, after I did that contribution, a lot of people started contacting me. Like, they contacted me and saying, hey, I have seen you as a contributor in YOLO. So we have I mean, the recruiter is actually contacting. Like, we are working on the, I mean, deep learning. Can you work for us? That is a question. So I was just amazed, because it's just a very simple contribution, and the opportunities that we are getting is very high. So this guy, I think, maybe like 20 to 25 age, and you can see here, he's actually the core maintainer and ML engineer of YOLO v5. Seems like an Indian. So he worked with many contributions. So this is like a muscle, I will say, the muscle power. So you can see here, YOLO v5 most commits after the creator. See, he is claiming. So he is one of the most contributing person. He also contributed to Microsoft, AstraZeneca. So that is, I mean, creating extra muscle for this guy. Okay, and you know, the payment that we are getting for the ML data science is very huge. Okay, compared to robotics, the ML data science is like, I mean, yeah, it's very high. Okay, and he's also having, I think, a yeah, a YouTube channel, it seems. Okay, so this is how we can establish ourselves. Okay, I think you got my understanding. Uh, like try to create contributions, and then it's like uh, creating more muscle power for us. So if someone, for example, if someone goes through this profile, they will be impressed, right? Because he already proved that he is one of the best engineer in deep learning. He works with stuff, he knows stuff. Okay, so that is what. So we don't need to write CV, we just need the GitHub ID. Okay, then if if someone can go through this project and all, then yeah, they can understand. So even one single project can change you. Okay, that can change. See, this guy actually contributed a lot of stuff. So that is what I'm saying, guys. It's very important to have open source contribution. Okay, yes, so we can conclude today. Maybe next session, maybe we can list out some projects, and I will also suggest you to work on the innovative ideas. So that will improve your creativity, and you will also interested to work in that project. Otherwise you will lose the interest. So I am seeing this actually, so that's why I'm saying to you. Okay, okay, so now we can conclude, and then it's a time for questions. So let me know if you have any question, guys. Let me know if you have any questions. You can either type or can ask. Any question, guys? I think it's clear, right? I think most of the things I have explained. Uh, so you can also think about, you can also find some interesting projects and try to contribute in the form of documentation, bug fixes, and all the stuff. Okay, so can we conclude? I think yes, we can conclude, guys. So see you next week, and we can discuss more projects, and then we can jump into the next chapters. I think, yeah, we have some more, I think 4 or 5 chapters left, and then we will be starting with ROS 2. I have some experience now with ROS 2. I'm currently working on ROS 2 Humble. So maybe after completing this, we will be jumping on to ROS 2. Okay. Yes, thanks for attending, guys. See you next week. Let me know if you have any questions. Okay. Bye, everyone.